Joining us here today. This is the Qimera ENC S-57 webinar. My name is Matt Wilson. I have in the background as organizers Jonathan Baudouin, our managing director, and as well Mo Doucette and Samantha Bruce. And so I guess without further ado, let's go ahead and get started. So I have just one slide here before I jump into the software demonstrations. And these demos will focus primarily on feature management in Qimera version 1.6, the new functionality, and it'll be pretty well tailored to the NOAA workflow. However, this should translate pretty well to folks outside of NOAA. I think that the objectives and the challenges in this workflow are pretty common throughout the industry. So in our new feature management workflow, we have some really unique value that's added from the Qimera design. Okay, there's no need to wait on your feature management. You can jump right in. So what I mean by that is what I often see out in the field is folks that are keeping spreadsheets on the side, or they have a Google Doc going, and they can't get into their feature management because they know they have some final processing that's pending to their bathymetry. So what we're saying here with this new version is go ahead and do your feature management, and then when you do the reprocessing, you can trust that your features will also update as well. Depending on how many features you have, this can lead to massive efficiency gains from these built-in linkages between the features in the bathy. So this is made possible by locking in a three-way agreement between soundings, grid, and feature. There's an entire NOAA and CCOM QC tool that's built around this very concept. I can say that having and maintaining this three-way agreement would have made my life a lot easier over the past 10 years. And frankly, it's something I've been wanting for the past 10 years, so I'm glad I can be one of the ones to help usher this new functionality in. So also along the way here, we're going to be looking at how Qimera can solve some common data quality issues along the way. So these are related not just to features, but we're also talking grid flyers, errors in the application of correctors, errors to vessel files, and so forth. So these are what you're looking at it right there. Those are the most prominent data quality issues in the workflows, and they have been for some time. It's kind of the same old story. This is for the past 10 years, these same data quality issues. So the inherent design of Qimera is built to mitigate, or in some cases, completely eliminate these common sources of error. So I'm excited to demo this functionality out. So I'm going to jump right into it here. And so these are pre-recorded videos. Just to make our time as efficient as possible here. And before I really get going, I just want to thank eTrack, because this is their data. They're longtime Quincy users, and as well are active in the implementation and the evaluation of Qimera. And so thanks for the data. And so I just opened a project, and I want to point out how the ENC is already in the background. I don't need to open this. I'm going to show you here. We have in our project preferences, there's this link to this system folder where I've downloaded all of the NOAA ENCs that are there. See, there it is. It's in the ENC root directory. And so all of the ENCs are there. And so wherever I'm working, the correct ENC is automatically displayed, which is, it's a little thing, but it's actually a really nice thing, because, we've all spent a lot of time trying to figure out which ENC we need and going and getting it. So the next thing I want to show here is I have these are Quincy DB files that are loaded in this project, 3 different vessels. And so this highlights the raw data extraction in Qimera. What we're doing is there's a lot of work up front that we put in to extract and utilize as much of the metadata that's in the incoming raw sonar data as possible. We're creating vessel files automatically. We're populating linear and angular offsets. And so this is minimizing and really just eliminating the errors in the transcription that's otherwise necessary. So, and what I'm about to do here is another nice little thing that it is actually a big thing, and that's quickly organizing these files. We have these different methods to group them. As you see here, you can regroup by vessel and day, which is what I'm going to do. So there we go. So now I have these 3 different vessels grouped by day. I also have, as I'm scrolling down, I have some SBETs that are loaded. We're going to apply those later as part of our post-processing. And as well, the sound speed profiles that are in the raw sonar data, those come through as well. These are the sound speed profiles that were applied in real time. So I don't need to import those separately. They're here. If I double click on one of those, there you go. I have profiles. They're linked to those lines in a real-time schedule, 3 different vessels worth. And as well, I have the timestamps and locations of those, because what we're going to do later is apply those in a post-processing sound speed strategy. Okay, so now let's get into some S-57. I have here my project layers. If I right-click, I can create a new chart. This is going to create, it's a QNC, a QPS nautical chart file. It's a working nautical chart file. So that's where I'm going to do feature management. I can create a new chart. I can add existing QNCs. As well, I can just import files. And so this is how I'm going to import S-57. In this case, it's going to be the composite source file. This is an S-57 file that NOAA sends out to the field that contain instructions for features. It contains assigned features, I should say. So I'm going to do that now. I'm going to import a CSF file. There it is. I got that in, and now the next thing I'm going to do is create another QNC layer, just an empty one, and that's where I'm going to do my feature management. So yeah, you see I have a lot of features in there. Now let's create another one, and we typically will call this, give it like the registry number name, and then followed by a final feature file. That's a pretty typical name there. And then so what I'm going to do is, you noticed in my CSF file, these are typically pretty bloated. There's a lot in there. And so I want to filter those down. I want to filter what I'm looking at. So I'm creating a filter right now. And so we have here all the S-57 attributes, including customized attributes that NOAA uses, specified per an XML file. So I'm choosing the assignment attribute, and I'm going to set that equal to assigned. So now I have a subfilter of only assigned features. I'm going to pare that down even more and add another subfilter and choose only wrecks, rocks, and obstructions, because that's what I'm interested in right now. There we go, obstructions, and I'll find the other ones in here. There we go. And so the result's real nice. I'm looking at only the assigned wrecks, rocks, and obstructions, which is exactly what I wanted. So now we're going to, let's go ahead and dive in. And first thing I might want to do is let's look at another view. I can, there's this nice function to put the charts on top with no fill. I turn off my lines. Now I'm looking at bathymetry with only features on top. I'm looking around, hey, there's an obstruction. Let's go and check that one out. I'm going to change this now and switch that off and actually turn on some transparency on my grid. That's just user preference, however you might want to do this. There's different functions there. I see something in the grid that looks kind of suspicious, but so I turn my lines back on, and I just want to make sure that everybody knows that this tool exists here, because this is pretty nice, where you're programming the path of where your selection box is going to go for point cleaning. I just wanted to demonstrate this, because this is pretty nice functionality here. So the point cloud's not loaded, but you can program that path as well. You can set it to go along the heading of a certain line. That's what I'm going to do right now, which is another nice little functionality. So I'm about to set that along this line here that's going to run over this obstruction. And now I'm pulling up this is our 2D slice editor I'm going to use. Here it is. Okay. And you're going to see there's a lot of noise in here. And so I purposely, this area, I left this not clean because I wanted to show what we have now. So this is up at the top right there. These are our spline filters. And I want to make sure everybody knows about these as well. So this is going to reject spurious soundings that are certain distances away from the grid based on these different levels of IHO tolerance. What they let you do is clean data really fast. Instead of drawing boxes like around these, zapping all these individual points like a lot of us are accustomed to doing, you can typically get rid of all this with one click. And so I'm setting that to a strong spline, and one click, and most of it's gone. There's a little bit remaining. I'll just get that. And then so if I move on, notice I'm updating with each step. This is a 50 centimeter resolution cube grid. So this is not an obstruction here. That's a side lobe. You can see as I move along this noise, you see this white dot moving back and forth. That's a side lobe along that bank. So I'm saying this is all noise. Normally we do more due diligence and be looking at our 3D editor, be checking side scan sonar and all that to sufficiently disprove that obstruction. But in this case, I'm getting a little carried away with the data cleaning. I'm looking at these side lobes, and I'm removing all this noise with one click. Well, 2 clicks there. And then updating a 50 centimeter resolution cube grid with each step. That was one click.
Can I interrupt you for a second?
Sure thing.
I just wanted to point out to the attendees that you can type questions in at any point in the webinar dialogue, and myself and Mo and Sam are in the background answering questions. We've just had a couple in already, but I just wanted to throw that out.
Okay. About to, I'll shoot offshore here in a bit to look at some more features, and maybe that'll give time to answer a few of those. Okay, yeah, there's some more noise. I got a little carried away with the data cleaning here, but it's one click, updating a 50 centimeter resolution grid. That's pretty noteworthy in my mind. So anyways, let's get back to the feature management. I'm parking my slice editor. And so then the next thing I'm going to do is, so say we did do all of our due diligence. We checked if there is side scan sonar. We've adequately disproved this obstruction. What I would do is I'm selecting it right now, and and so this was really important to us in our feature management. And when going through these workflows, you're very often moving features from one layer to another. So we want to accomplish that as quickly and as easily as possible. And so I'm moving this from my CSF into my final feature file, and we have the option to cut and paste or copy and paste, just like you see here. It's pretty easy. In this case, I'm just going to do a copy and paste. So that's pretty streamlined. We don't have to delete it later if we did do the cut and paste, but I'm going to do the copy here. So. Okay, there it is. I have one feature in my feature file. It's this obstruction. I'm editing the attributes on it. And so that's what I have initially from the CSF, and then I'm adding other ones. And there we go. Remarks, recommendations, description, images, office notes. These are customized NOAA attributes. And so what I'm going to do is tag this for deletion. Okay. And yeah, you could put in some kind of remark in there too. That's a typical one: obstruction disproved via object detection, multi-beam, something along those lines. So, okay, I'm going to go offshore here. We'll do some more feature management. You said there's a couple questions, JB?
No, not yet. I was just pointing out that people have questions into the question widget, and then we can answer that behind the scenes.
Okay, gotcha.
Also, there was one question earlier. People were wondering if this was being recorded and if we'd make it available. And what we plan to do is record it, of course, and then we'll put it on YouTube as we usually do. So we'll send a link out to that after the webinar and the usual follow-up emails we get from that.
Okay. All right. Well, I'll just keep moving along here then. So I'm gonna move offshore, and there's a couple wrecks, an obstruction as well. We're gonna look at. So here we go. So this is a wreck. It actually, I mean, you can see something there. It looks like a pile of junk. It's but we're going to go take a closer look here. You can see this wreck is from 1997 from the composite source file. But we're going to use our 3D editor now and take a closer look at this thing. And so in these waters, we're pretty shallow right now. And so this supports the workflow where what I want to do is we have 2 feature management workflows where we're getting features into our final feature file. The first one is the traditional way of looking at this, where it very much has safety of navigation as its priority, and we're going to choose a reliable least depth sounding on this feature, and make that represent the feature. And then so that's what we want to do in this case where it could be a danger to navigation. So I have this view, and I'm going in and I'm looking and making sure my grid is being displayed, my cube surface is being displayed, and then what I'm going to do is tip this horizontally and kind of look at it from a few different angles, and then I'm going to zoom in, and we have a utility to automatically select the shoal depth. Normally I do other things like checking attributes of this sounding to make sure it's reliable. But in this case, you assume I've done the due diligence, and so we have this button to create ENC point object. I click it, bam. So I'm making an ENC rec object directly from the sounding And the intriguing thing to note here is my valsow is already populated with the value from that sounding. And then I have these customized Qimera attributes down there that are linking this feature to a particular beam, ping, line, and system. So this is the linkage between the feature and the sounding. So I label it as a dangerous wreck. And now the next thing I'm going to do here is add some more attributes that would be typical for a wreck. Things like source date, source indicator, the text sow, the water level, remarks and recommendations, description, so forth. Now the next time I go to create a rec, all of these will already be, these attributes will already be ready for me. So this is just the first one. So now let's see how, change the watt lev there. And then, so now we have the link between feature and sounding, okay, which is important. Now to complete the three-way agreement, I'm checking that box to set a custom hypothesis. I say okay, and we notice in the background that locks in the grid. So now this is locked in, grid, feature, sounding. Now the values can change, but the important thing is that they maintain agreement. So we can have good confidence in this is going to meet specifications and completely eliminate what is a very common source of error. Now the next thing I'm doing is, and just to tell you about a little bit about how feature management tends to work in NOAA is, you could make the argument that this is the same rec that's charted over here. And so you'd be better served to just simply mark this as an updated feature. We tend to veer away from that in NOAA. That leads to a lot of gray area if you don't know if it's for sure if it's the one you're updating. Instead, we prefer to add the new feature and delete the old one, even if it's obviously the same feature. The way I think about it is you're adding a new report of that feature and deleting the old report of that feature. It makes it a little clearer in my mind. So that's what I'm doing here is I'm taking the old feature and I'm copying it over to my new layer and then marking it as marking it for deletion. There it is. So I got it, and very easily just going to bring it over. Well, I already did. Now I'm going to just mark it as a deleted feature. Yeah, you see the dates from 1997. Okay, I'm going to add the description field. And mark it for delete. Okay, so now this process, I'm going to go through this 2 more times. I'll jump ahead because we don't need to see the whole thing. It's just replicating what I've just done. I'm going to do this again for there's an obstruction next, and then another rec. So here we are, we're looking at this. I'll jump ahead a little bit. There is a pretty significant obstruction down here, and I'm going to look at it in 3D editor. Again, this is the workflow where safety of navigation is paramount in these depths, so I'm going to nominate the a reliable shoal depth for this thing. Here they are, these prominent triangular obstructions here, and just replicate the same exact process. So I'm creating a feature from the reliable shoal depth. I'm using the utility to nominate what is the shoal depth for me and tagging it directly as an S-57 feature. Okay, changing it to an obstruction. I'll jump ahead here a little bit. And there we go. I just locked in the grid, so that ensures the 3-way agreement. And then what I'll do is go back and bring over the old feature report to mark that for deletion. And now I'm going to jump over to yet another area where we have one more rec to look at. Here it is. So this one's a little better charted, and so again, I'm going to look at this in 3D editor. My concern, once more, we're in the waters where this is a dangerous wreck, and we would prefer to have a reliable shoal depth to represent this feature. So let's look at it in 3D view. There it is. And so once more, I'm nominating the shoalless depth and converting it to a feature, ensuring the grid maintains agreement. Okay, and there it is. 3-way agreement, sounding, grid, and feature. Okay, and so now the next thing.
If I can interrupt you once more.
Sure thing.
I just wanted to point out that three-way agreement that works with the cube grids, because the cube grids, you can set a custom hypothesis. If you did this entire workflow with a dynamic surface, the dynamic surface is always just the average of the soundings in that cell. So that's just an important distinction here for people attempting to do this in a NOAA workflow. That three-way agreement, or trinity, we sometimes call it, works with the cube grid.
Thanks for pointing that out. Yeah, that is an assumption that I often make, that NOAA, we're pretty much always using the cube grid, so that very much is applicable to the cube grids, this workflow. So the oops, I advanced the slide there. Okay. The last thing I'm going to do is just bring over the deleted report of that feature. And then I'll do a little bit of housekeeping here. So what I have is, advance that a little bit more. And we're calling this a deleted feature. Okay. So now what I've done is I've added 3 new features and then 4 reports of deleted features. So now the subfilters I have aren't as relevant anymore. So I want to filter these by the description field, which is informing me whether I want, whether these are new features or deleted features. These are very common kinds of filters in the NOAA workflow. So I'm removing the subfilter and removing the other subfilter. Okay, and now I'm going to add a filter that's a little more meaningful to me based on that descriptor field. Okay, and so the next thing we're going to do after a little bit, I do a little bit more housekeeping. We're going to notice I wasn't really populating attributes. I was populating a few, but not many. As I was going along, it's more efficient to wait until later, because what we're going to do is update the attributes on all of these features in a more efficient manner. Rather than doing them one by one, let's just do it all by once, because a lot of times they're going to share the common attributes. Here you go. I have these sorted by new features and deleted features. So let's take a look at my new features. Now, keep in mind, I only did this 3 times. There's only 3 features here. It's often the case we have 200 or 300. So keep that in mind. Okay, so now I have super selected these 3 new features. And so now any attributes I change is going to update the attributes on all of the features that I have selected. So this is an efficient way of working. Notice that my valsal is painted orange as a warning, saying, hey, don't mess with that attribute because that's different for each of these. But everything else, we can go ahead and modify. So I'll start with the source date here. And so this is from NOAA specs. I put in today's date. Typically that would be the last day of survey, or often it would be. And this is, again, straight from NOAA specs, where you're tagging it with the registry number there at the end. And then so when I say okay, we've updated that on all of these. So now I'm going to select just the recs and populate another attribute, just so we see our source date, source indicators in there like we wanted. And for this is a typical remark we might give for a rec. It's verified via object detection multibeam. Okay, and then I'll do the same thing with the obstruction. Just a little bit of housekeeping here. I'll jump ahead a little bit, and there we go. Typing in a remark. Okay, and there we go. So now I did that feature management process with 3 features. Now let's pretend I have 300 in here, or 400, 500, 1,000. It's not unusual. It happens. Now the next thing we do is say, okay, now we have further processing to do. So what was expected previously was I'm going back through every single feature and finding a new least depth to make sure it updates, or to make sure it's in agreement with the updated bathymetry. So I have to go back through and find a new least depth, which is painstaking and pretty awful to have to do. That's why people typically will hold off on doing it until they have confidence in the final processing being done. And so that's what we're eliminating with our new workflow here. We have these valve sows. These are at mean lower low water right now. E-Track, they are users of Quincy, which has a lot of flexibility in the acquisition capabilities. What they're using a Marine Star RTK solution with a VDatum separation model in real time. So they're getting mean lower low water in real time, which is very efficient for acquisition. They know exactly where their coverage limits are in real time. So and when I bring this data into Qimera, it's already at mean lower low water. I still have post-process SBETs I'm going to apply to further increase the accuracy. And as well, I have the sound speed profiles are still on the real-time schedule as they were acquired. I'm going to adjust that to a nearest and distance within time strategy. That's generally preferred in post-processing. So I turned on one of the SBETs. You see it here. Yeah, there it is. Yeah, so I'm going to apply these SBETs. I'm going to adjust the sound speed strategy and trust that my features will all update as well, which is a game changer. Okay, so the first thing I'm going to do here, I'm looking at the processing parameters for one of my vessels. Okay, and I'm going to switch that to nearest and distance within time. I'm going to choose 4 hours, and then I'm going to apply that change. Now this, I'm going to pause it, and just I want to point out this is one of the second design pillar of Qimera. It's the guided workflow. I've made a change to my processing parameters, and so it's prompting me to reprocess. And so I don't need to know, I'm not responsible to know what processing exactly needs to be done. Qimera is taking that for me. It's taking that on for me. If I want to know what needs to be done, I'm actually going to defer this processing, and I'm going to check. This is one of my favorite things about Qimera is I'll defer the processing and check what processing is pending under these edit modified flags. And I made a change to the sound speed strategy. That's why that box is checked. Okay, now I'm going to go in here and adjust the parameters further. And I'm looking at, so under this position, motion, and heading tab, these are all my different sources of such. Under position, these are all my sources of position, and there's my post-process SBET. So I automatically know all the sources of position I have loaded. And furthermore, I know which one's being applied because it's the one that's on top. If I want to adjust that, it's simply a matter of moving my SBET on top. Now that's being applied. Similarly, with the vertical referencing, I'd have my SBET there, and it's simply a matter of moving it to the top. And now my SBET will be applied. There's my mean lower low water separation model. It's already being applied from Quincy. I'm saying okay. As a demonstration, I'm checking the modified flags again. And again, so here's all the processing that's pending. Sound velocity, position, and height, because I just applied the SBET both horizontally and vertically. Okay, and so now I'm going to go ahead and reprocess. And I'm going to make the same changes. That was just one vessel. So I have 2 other vessels with different SBETs. So I'm going to apply those as well. Again, the same way, going into my processing parameters, first adjusting the sound speed strategy, and then putting the SBET on top horizontally and vertically. And notice I'm processing right now in the background, and I'm still doing stuff. That's a big, that can really save you a lot of time. I'm not having to wait for this processing to finish. You can actively QC or do further, add further processing queues as I'm doing. I'm not waiting for that to finish. That's another really nice thing. So, okay, the last vessel, I'm putting the SBET on top horizontally, vertically, and then kicked off that processing. And now I'm just going to sit back and wait. And I have three features there, and we're watching the valve sows. And see, I'm pointing at the wrong one. It's actually this top one. Watch that one first, the 3.16. And okay, there it goes. So it just updated. Again, it's the change was on the order of centimeters, but if those are not in agreement, that's enough to give you a very bad day per the NOAA specs. So, okay, yeah, I'm processing the next vessel's almost done. Now we're looking at the valve sow in the middle there. That's a 6.02. And again, the change is not dramatic because it's just applying a new SBET with the sound speed strategy. But again, it's enough to break NOAA spec. There it goes. And one more vessel. we're waiting for the processing. I'll jump ahead a little bit on this one because this has more lines, and we're watching that last number there, the 4.56 right here. There it goes, 4.693. So with 3 features, you know, is it that big of a deal? Maybe not. It saved me a little bit of time, but again, it's when you have the 200, 300, 400, up to you know, 1,000, even more than that. We've all been there, so it's gonna be a huge game changer. Okay, and now I'm going to talk about a different workflow where, let's say that you know, these 3 features I nominated from a single least depth sounding. There's another school of thought that says, you know, if we're in deeper water and you know, safety of navigation isn't as much of a concern, that single least depth, how do you know that's not noise? That could just be noise. Why not nominate the feature depth from what is the statistical best estimate of the depth? In this case, it's the grid node. So we're also supporting that workflow where you know, you're creating a feature directly from a grid node, which makes a lot of sense if you think about it in those terms. I think it's good to have options here. The traditional workflow we'll always support because there's times for safety of navigation where you want to ensure a single least depth. So now what I've done, I've converted my grid into these plates, and I'm looking at the cube depths. I'm going to turn on my cell info here, and I'm looking at the information for these grid nodes, and I'm just going to grab the shoalest point, or the shoalest cube depth, rather than the shoalest sounding. I'm going to get the shoalest cube depth. There it is. It's that yeah, okay. 30.36 is the number to remember, and I should have said that this is a different project where I imported all the data. I removed the mean lower low, or the separation model. I removed that separation model. So we're looking at ellipsoid heights right now, and so we have here in our ENC editor the ability to create features directly. You can create point features, line features, and area features. In this case, I'm going to create a new point feature directly from this grid. Click right there. The valsal is automatically populated with 30.36. That's an ellipsoid height. And as well, you notice my attributes are a little different now. Now they're linking this feature to a particular grid and to the cube depth, which is exactly what I wanted. Okay, and so yeah, having removed the separation model, it's just a little more of a dramatic update. You're going to see it go from an ellipsoid height to the mean lower low water. And so let's, I'll click on it here in a second. I'll zoom out a little bit. And turn my lines back on. Yep, okay. And then what I'm going to do is select my lines. I'm just going to kick off the processing first. And it's the same processing we were doing earlier, except this time I'm going to add the separation model because I had taken it out earlier. Okay, nearest and distance within time. And once again, put the SBET as priority, both horizontally and vertically. And this time I'm adding the separation model. There it is. Okay. All right, and then I'll kick off the processing, and then we're going to watch the feature valsal move from the ellipsoid height to mean lower low water.
So Matt, if I can interrupt for a second, what's the big value then that brings from your point of view? You've done this for a living for a number of years, whereas I've not.
What's that, creating a feature directly from a grid?
No, the point of being able to get to your feature management right away, looking at a point of view from a field unit.
Okay, yeah. I mean, it's time savings is what is it. It's both time and accuracy that's at stake here. You know, if you only have a few features, it's pretty easy to make sure those are telling you the same story as what the grid is. It's when you have, you know, 50 plus, and we routinely get these with hundreds of features, and then so the case becomes it's a lot of time and effort for the field. You know, it's a requirement, whether it's explicit or implicit in specs. Your features need to be telling you the same story that the bathymetry is telling you. That is in specs. And so the problem is the software solutions have never given you any help there at all. It's been like an industry assumption that your S-57 features need to be completely separate from the bathymetry, and that's where we get burned. It's been the 10 years of reviewing surveys. It's an ongoing issue. It never goes away. So what this does is make that whole thing completely irrelevant by linking those up. So now field gets started right away on their feature management. They do all the updates to their processing, and there's those linkages to the S-57, which updates also. And so that saves you a ton of time, and as well, it makes sure you're accurate.
Does this also mean that you can, if you have a 20-day job and on day one you've got 1 day of multi-beam data, you can get straight to work on your feature management?
Absolutely, yeah. You could just you could go ahead and create your new features, and with those linkages, you can just trust they're going to update. Just jump right in. Absolutely. Okay.
Thank you.
You're welcome. No problem. All right. So we're looking at this rec here I have in as a new feature. It's obvious which one it is. It's the 30.36, and I'm doing the processing right now. I'll jump ahead a little bit, and we're going to see it. There it goes. It bounced to a 4.76 automatically based on those changes and including the VDATIV separation model. And then the last thing I do here is just take a look back at the grid, and so I think it was a 4.756 was the val-sal, and I just want to confirm I'm looking at my cube depth. It's a 4.76. Those agree to centimeter accuracy. I can give a sigh of relief. I'm with that's I'm not going to get. I didn't break any specs there. It's going to go cleanly through RSAs and so forth, and no acceptance procedures. And okay, yeah, there we go. That was feature management using our new system and demonstrating the value there. And I have one more slide I want to talk to here, and then I can answer some questions if there are any. This is just called I want to talk. I kind of hit each one of these as I was going through it, but I just want to reemphasize how are we improving data quality. So these are some critical takeaways that a lot of these I didn't know about all these when I was that Qimera had all this, and I think it's important that people know this is out there. These things that we're doing. One is the rich data extraction. That's what I was talking about. How we've done all that work up front to extract and utilize as much as we can from the incoming raw sonar data. We're creating vessel files for you automatically, populating the linear and angular offsets. So what that does is eliminate errors in vessel files. It's which is one of the most common sources of errors that we see in incoming survey data. We're also extracting sound speed that was acquired in real time, which alleviates the need of alleviating the need to re-import those later, removing any error in that import. The automated spline filters. I spoke to those a little bit during the demo, and this speaks to grid flyers. The best answer I have for grid flyers, what I would do is I would definitely clean my data. After everything I've seen with flyers, I would clean my data. I'd use Cube. Of course, that's a NOAA spec, so of course you're using Cube, but that further reduces the chances of noise showing up in your data. And yes, I would use other tools out there like Flyer Finder. I'm always going to be in that corner for Flyer Finder. I'm going to use all these tools because using them all together gives you the lowest likelihood of flyers showing up later. Okay, now what's nice about the spline filters is that I understand it's that cleaning data has a cost because it's so time consuming, but that's where these spline filters come in, is how it's remarkable how fast you can clean the data. There's a big time savings benefit there with the added benefit of wiping out grid flyers. Okay, and next is the correctors. The improper application of correctors or in the reprocessing afterwards is actually the highest occurrence of errors in the NOAA workflow. It's almost 50% of the time there's errors found in this. So what we have in Qimera is this intelligently managed processing state, which ensures the proper reprocessing. Qimera is taking away the responsibility, taking that away from you and ensuring everything's done correctly with one click. Because what typically happens, what I'm used to, is after we apply correctors, then there's these conversations that happen where people are asking, like, do we need to reapply sound speed or do we need to reapply vessel offsets? And no one's really sure. And so that usually people will just out of an abundance of caution just do a lot of redundant processing, or they're going to make mistakes. So this is where this intelligently managed processing state is really going to help. It's iron that out. So, and then of course the last one, I just spoke to it, during this webinar, our innovative feature management functionality. And obviously, the more features you have, the more efficiency you gain from using it, and has the side benefit of completely eliminating what is another very common source of source of error, which are the feature to grid disagreements there. So, I mean, looking at all these together, it's vessel files, grid flyers, correctors, the feature to grid thing. These are all the most prominent issues in the workflow that we're attacking directly and making improvements, in some cases completely eliminating. So, okay, that's everything I had. This is my last slide, so I'd be happy to answer any questions if any of those popped up, or and I'd also just thank everyone for your attention and for tuning in. I appreciate it. So, did we get any questions during that?
Yeah, Matt, I do have a couple Mo and Sam and I have been answering behind the scenes. I think they're worth sharing, though. They touch on questions that probably other people have. But before we do, at this point, people start to peel off from the webinar. We wanted to extend the offer. If anybody is interested in having an evaluation version, please just get into the question widget and type eval and give us your company name if it's not immediately obvious from your email address. We'll collect those at the end, and then the sales team will get in touch with you to get an evaluation version of Qimera with the ENC Plus add-on. So we can follow up on that. So I've got a couple of questions here. Let's see. I'm just scanning them. Somebody had asked, is it possible to make a sounding designated without being associated with a feature and have that designated sounding represented in the grid surface? I think we've always been able to do that with Cube. You could set a custom hypothesis from a sounding, and it would override the Cube hypothesis. That's a completely independent mechanism from the S-57 capability. That's always been there with Qimera. What we've done is hooked up into that. So if you did create a sounding S-57 object from a sounding and you were using Cube, that's the three-way linkage that Matt touched on. Matt, did you have anything to add to that before I move on to the next question?
No, yeah, that's right. Yeah, we've all the set the custom hypothesis to is essentially I mean that's in other words that's designating a sounding, and so you can tag the ENC capability onto that, or do it separately, right? So.
Okay, and then one more question that came in was, can you compare your results from the SVP strategy with cross-check lines when you change the parameters? I typed in that you can use the cross-check tool. You could also create separate dynamic surfaces from your cross lines and main lines, and you can difference those surfaces at any point. Differencing the surface gives you overall statistics, grid cell versus grid cell. You can get a histogram. The cross-check tool compares the soundings in one data set against a grid in the other, and you can tabulate that output as a single histogram or by beam angle as well to see if you have a refraction problem. Anything to add to that might spring to mind, Matt?
No, that sounded good to me.
Let's see. Somebody asked, is the flexibility of this feature management also going to be rolled out to Fledermaus? That's not currently in our plan, but what you can do with this feature management add-on is you can use that with Qimera Clean. Qimera Clean lets you bring in dots and grids, and you can validate your dots. You can't do any mathematical reprocessing, and it's at a lower price point compared to Qimera. That's the replacement package for Fledermaus users who had the FM Hydro bundle or the FM Pro bundle. So Fledermaus users do have access to Qimera Clean, in which case they can get the ENC add-on, and that lets them get in and try that out relatively straightforwardly. Again, Matt, anything to add to that? No, nothing to add from me. That all sounded good. And then I think that might be it that we have time for. So yeah, those are the questions. So if you want to wrap things up there.
Okay, great. Well, yeah, I'd thank everyone again for tuning in, and yeah, we'll be happy to follow up with all the attendees, and again we'll have this posted up on YouTube and sending it out to folks that registered that maybe missed the live viewing here. We'll follow up and we'll be in touch. And yeah, just thanks again, everyone, for tuning in.